This is a BBC NICAM 3 decoder. Now, in order to understand exactly how this thing works and sort of appreciate its history, I do have to give you a short, well, what will hopefully be a short history lesson, so do bear with me for a second. You see, in the 1970s, FM stereo broadcasts were starting to become a thing that the BBC would like to roll out across the whole country. However, there was a bit of a problem, which was the only way to send audio across the country in those days was to rent an analogue circuit from BT. And that was all very well if you were only sending the circuit a mile or so, but if you were sending a circuit from, say, London to Scotland, by the time it got there it would sound like you were talking with a sock in your mouth. And this was only made worse by stereo, because then you would have two channels that might be slightly different, which meant by the time it got to the transmitter, it would have a very odd stereo image. Things would sound like they were coming from odd directions. Clearly the way around this was to send the audio digitally, which was a fairly new technique at the time, or at least it was for broadcast audio, that anyway. And the BBC's first system involved sending 13 channels of PCM audio on a BT circuit to selected transmitters, and this worked very well. But the next problem was, of course, PCM isn't all that massively efficient with its bit rate, so how do we squeeze more audio channels into the same channel? And the BBC came up with NICAM. Now, NICAM stands for Near Instantaneous Companded Audio Multiplex, and all that means is that rather than sending each sample of audio individually, we actually take, I think it's 32 samples of audio from each channel, we stick them all in memory, we work out what the largest one is, and then we only transmit 10 bits, the 10 bits of each sample and the range, and that saves you a fair bit of bandwidth. So that's what this unit does. This is the Mark I system, which was designed in 1980 and was used right up until I think it was 1990 when the Mark II system came out. Now all that happened there was this system, these decoders, you would have had 3 of these for a multiplex for 6 channels. Each one of these boxes produces 2 channels for a stereo pair, and it takes up 4U of rack space, whereas the new unit takes up 6U of rack space, but it does all 6 channels in that one box. Now unfortunately I don't have one of those, but if you look up online, Matthew Millman has been able to get access to one and has lots of in-depth analysis of how it worked. But I have a Mark I, so let's have a look inside this and see what makes it work. First of all, I'm going to spin it round and we'll have a look at the back connections. Now around the back we have our 2 analog outputs, and this is just the same analog outputs but on a single connector. We have our LNE for power. We have a nice big 37-pin D-type for the connection to a demultiplexer, which I'll explain in a second. And we have an input for HDB3, which I'll also explain in a second. And we have a variety of clock signals and things for slaving these together. We can also undo these 2 screws, and the whole back hinges off, and we can see the back plane. And if I lift you up for a second, you can see all the connections in the back. You can see the transformer. We actually use proper transformers for the balanced audio, and you can see that the demultiplexer connection isn't actually plugged in. That should be in there, shouldn't it? But again, we'll get to that. I shall explain that in just a second. Around the front you can see we have 2 power supplies, one that produces 12 volt and 5 volt and one that produces plus and minus 18 volts. We also have a blanking plate here, and then behind here we have, I think it's 8 cards in total. Yeah, 8 cards. So we'll just have a look first of all at the power supplies. These are more or less what you would expect for the era. So we have a lot of linear electronics in here, and it produces a lot of heat. Similarly, if I just slap that back in there and take this one out. Now this one's quite a bit heavier because it has a big transformer in it, which you really don't see anymore. And again, lots of nice linear electronics and things in there. So those are very nice. And then on the back, which I thought was quite odd, we actually use what's essentially a 9-pin D-type with some of the pins removed to bring the power from the back of the crate into each power supplier. Now here you might have noticed that looks like a blanking plate, doesn't it? And that's because it is a blanking plate. You see, the idea of this system, and you can actually see what the converter number would have been in there, and you might be able to see the connector down the back. You see, BT were using circuits, we're using a system called HDB3. Now I don't want to get into the whole details of exactly what HDB3 is and how it works, but essentially it was a 2 megabits per second digital carrier, and this NICAM system was explicitly designed so that 3 NICAM multiplexes would fit into a HDB3 circuit, hence 3 of these crates, and that would give you 6 total channels. So how this worked was there would be a sort of a master decoder which would have an HDB3 card. HDB3 would come in the back, it would demultiplex the HDB3, and then the ribbon connector that we saw on the back would be looped down between each of the decoders to feed each one individually. And for critical installations, there was also a system of a reserve facilities unit that I can't remember the proper name of, but essentially it monitored, you had 1 spare, so you actually had 4 of these, and the unit was able to hot switch a failure to the other coder so that you wouldn't lose the whole lot of them. So that was how that was intended to work. The clever thing with HDB3 was, of course, since it was just 2 megabits a second, that also meant it could be sent across microwave links intended for video, and indeed the BBC made use of this in some of its self-provided links. Taking the cover off the front, you can see our 8 cards here. The first one here is the CO103 card. This is the serial to parallel converter card, so there's a load of logic on there, and what that's doing is it's taking the serial demultiplexed NICAM stream from the HDB3 card and turning it into a parallel data bus that the rest of the unit can work on. Next we have the monitoring card, and you'll see I suspect this one is slightly newer than the rest of the cards because it's a nice green circuit board, more like what we would be used to seeing, as opposed to the sort of beigey coloured ones that the rest of the unit has. And this is monitoring all the other cards in the system and providing the output on the rear connector for the monitoring unit. You can see on the back here, this one has had a few bodges done to it. And interestingly, that is a theme of this unit, and that makes me suspect that it must be one of the very earliest ones of these. In fact, just thinking about it, if we look at the serial number, well, the serial number is 197, which would sort of suggest unit 97 perhaps, but then I don't know if they counted the coders and decoders separately or together, and I don't know, so that doesn't really mean an awful lot, to be honest. Next we have the UN26/49, and this is the card that is taking this is the interpolator card. This is taking the NICAM data and correcting any parity errors that are in it and showing on the front here how many errors there are, showing the error rate. And then this card passes its output onto this card, which is the UN26/42, and this is the actual NICAM expander. So this is taking the 10 bits from the data stream and the range code, which comes from the next card, and making turning the 10 bits back into 14-bit samples, which then eventually go off to the DACs here. Again, there have been some budges done. Next, we have the CD3/38. This is the range decoder card. So again, whenever you get your block of samples, this checks the parity, or sorry, it doesn't check the parity. It checks the signaling bits and gets the range code for that sample block, which goes back to the expander here. On the next one is the UN27/10, which is basically just a card with lots of RAM and ROM and things on it that are used by the other cards. And finally, we have the special sauce, which are the 2 DACs. Now, I was quite surprised that each channel is its own DAC, but it just shows you how far we've come. That, I mean, to be honest, this entire crate could fit in a chip smaller than your fingernail nowadays. In fact, probably 6 of these could fit in a chip smaller than your fingernail these days. But yes, so this is the DAC. So, well, to be completely accurate, I believe these are the DACs, and they produce, you can see here we have all the lots of filtering and lots of exciting stuff going on there that I am not in any way qualified to explain, but yeah, very impressive. This one has a nice wire across here. Interestingly, this one has a whole resistor network soldered onto the back. So I would love to know what the story behind that is, but unfortunately, just at this moment in time, your guess is as good as mine. So that was the NICAM 3 decoder, and this one is heading off to the Broadcast Engineering Conservation Group. So hopefully, eventually you'll be able to see it working there. I don't know if they'll be able to get it to work or not, but that would be nice. Certainly this one does power up, as you've seen at the start of the video, but we are missing one of the 12-volt rails. And I don't have, sadly, a matching coder for this, because obviously the nicest thing would be to power this up and actually see it producing audio, but not going to get that today. So hope you folks enjoyed that.